easily available from different forums. That is called open source. And previously in the second generation, third generation, even with the fourth generation, most of the network software feature are proprietary. Proprietary means they are under the control of the vendors. Vendor have the right to make changes and make money out of these features. So on the other hand, the 5G technology is much more open and used by wide range of the applications. Second part of this slide is called features. We have vendor has a limited features, so you are rely on the vendor features only. On the other hand, with the open system, open community based system, a customer may have a variety of features under open source software. You remember that it's easily to upgrade a software based system as compared to hardware based system. Even you can configure software based system easily from any remote location, which is not possible for hardware centric equipment. Simple, another feature is that failure is possible in case of carrier network software, which you have very little or no control. So the mindset of the carrier or vendor specific is that once you have a failure at the vendor side, you do not have the knowledge to make or bring the system in an operational position. So this slide shows that the power of open system versus the closed system or the and closed software which is provided by the vendors. Now this is an exciting part of the mobile network. This is a classical network of, you can say that, 3G, 2G. But on the other hand, if you look at the diagram on the left side, you have a variety of devices, including a 2G mobile phone, 3G mobile phone, 5G, and 4G mobile phone. And on the base station side, base station is nothing but coverage provided by antenna to its user. Is generally shown in the form of hexagon or a cell. It consists of a physical tower which consists of baseband unit and radio unit. We will discuss both baseband unit and radio unit in detail. And on the other hand, in between the core network, there is a backhaul that is provide you connectivity between the base station, that is tower, to the core network. Generally, they are in the form of fixed lines. In our country, it's provided by Pakistan Telecommunication Limited, or big cellular companies also have a fixed line. Or in case of some terrain which is in which the lines deployment of lines are not easy, we may use the satellite and microwave links to connect our base stations with the core network. Look at the core network. The first part of the core network is called the edge router. Edge router is actually the core router or the gatekeeper router, which provide the connectivity between the main network to the core network. So let us discuss these particular areas of the simplified mobile network. This is a simplified version. This is not the 5G 5G network for the radio network. Few discussion about the network of the mobile communication. It mainly consists of a mobile divided into regions. You have already seen our antenna towers in your neighborhood. Each tower supports number of users and it has coverage. And that coverage is showing you that, and these towers are spread in all over the, not only the cities but also in the far flung areas of the Pakistan. The base stations are typically mounted on towers, with site owned by tower companies and equipment owned by telecommunication in most developed countries. Remember, this is one of the most costly part of the network. The tower rent is in 50,000 Pakistan rupees to maybe 2 lakh, 3 lakh, 4 lakh. So if somebody has a mobile tower at the top of the roof, they make a good money out of it. So companies spend a lot of money, not only the capital investment, but also the operational investment on these towers. This is one of the most cost-centric part of the network. So why we are discussing this thing? Because if we have to increase the number of towers, it's not feasible for big companies to have increasing number of towers in a large number, because it takes a lot of heavy investment. So let's see. In each coverage area, we have mobile devices, for example, smartphones. And these smartphones are connected with base station, as you already know that, through radio signals, where these signal is transferred to the core part by high frequency to the edge router. Remember, we cannot use high frequency for the communication in the neighborhood. The high frequency generally used for long haul communication, means to carry the bulk data from the switching is one switching station to another switching station. And finally, it consists of two important components. Any mobile station tower, beside the tower, it has baseband unit and radio resource unit. Baseband unit used to generate and process digitized baseband RF signal. Remember, whenever we are transmitting a signal from our mobile phone to the tower receives the signal in the form of analog signal, and the component responsible for receiving the analog signal is called radio resource unit. The radio resource unit is responsible for receiving your analog signal from the environment, from your mobile station. So from your mobile phone to the tower, the signal are in the form of analog signal, and the component responsible for capturing these analog signal and amplifying it is called the radio resource unit. And is the another name of radio resource unit is called the analog unit, because it use the analog signal, and it transferred it digitize and hand over these RF signal to baseband unit. Baseband unit perform number of various operations on these digitized signals, so that it can be sent to switching station. So in simple words, baseband units the digit has processed the digital function, and the radio resource unit is perform the analog function. And let's look at what are the problems we going to face when we need more towers. Remember, increasing number of towers will require a very large amount of investment, and it is not practically possible to increase the number of antennas in the city for 5G communication. And for 5G, we require large number of uh, antenna facilities, which is a very heavy investment. So let us read these lines before, so we can discuss more about this particular challenge. One of the challenge in 5G is called densification. 5G will require tremendous increase in number of base stations since the enhanced mobile broadband portion of 5G introduce much higher frequency spectrum. This process generally referred to densification raise a scale challenge. I will spend more time on this slide because it requires more depth information of 5G. Remember that in 4G, 3G, and 5G, the difference between these technologies is the use of the high frequency spectrum. The spectrum of 5G generally is in the range of few gigahertz to few hundred gigahertz. The higher the gigahertz, it requires a smaller size of the cell. If we reduce the size of the cell, we need to have more towers. So if we have more towers, it's not easy to increase the number of towers in the city because of number of reasons. environmental as well as some financial reasons. So that increase in the number of sites is a challenge, and this increase of the number of base stations tower is called densification. Densification means in 5G you need more connectivity antennas available in your city at almost each corner of the city. So remember, it's not possible to have the 5G networking capabilities under the existing 4G or 3G infrastructures. We need to change the infrastructure, redesign the infrastructure. This is what we will see in cloud-centric radio access network and software-defined networking. This is the core part of today's discussion, and we're focusing on the challenge of 5G. Remember, 5G use the frequency in gigahertz. The gigahertz frequency is also called millimeter wavelength, or in other words, is called gigahertz frequency. Gigahertz frequency is different from radio frequency. It has the capability of carrying much more data, which can support much more higher bandwidth, but it can penetrate by vegetation, including forest. It can affect by the rains. So we do not have a very large coverage area of the base station. We need a small coverage based towers that can support this high frequency. Remember, the one of the major difference between 5G and the previous 4G and 3G is the spectrum. The spectrum required large number of closely spaced towers, which is a very big financial investment. And this is the challenge. We will in-depthly look at the channel before moving toward the solution of this challenge. Definitely, today's discussion is about the solution of this challenge, that is called cloud-centric RAN and software-defined network. So first, the problem is being discussed under these 6 slides. The problem in the 5G is called the densification, and densification means due to the high frequency usage, we need a closely placed towers, and these closely placed towers is a big investment, and not only it's a financial challenge but also an environmental challenge. So this is a problem we have discussed so far, densification. As already discussed, that the number of increase will cost major capex or capital expenditure. You need to have more units of the antennas in the given areas compared to the 4G and 3G, which is a very heavy capital expenditure. You need to spend more on the first time. Likewise, on daily or the monthly basis, you have to spend time operational expenses on these large number of base stations, which increase the cost of the whole network. And in traditional radio access networks architecture, each site required dedicated baseband unit and radio resource unit, which have another allied requirement including power, cooling, and routing function. Have you ever seen a site? A site consists of a big tower, radio unit, baseband unit, a generator, cooling systems, and these all different component of the base stations required much more investment. And if we deploy such kind of network, a traditional network in 5G, it's not possible for company to make money, or it's not practically possible. And this process, this word densification is very important in today's discussion. So remember, densification means you need more base stations compared to 4G networks, because the frequency or the spectrum used in the 5G need a closely placed base station for providing services, reliable services. Finally, we look at these Densification slide 5 of 6. Without rapid mass deployment, the spread high frequency will be incapable to provide extraordinary increase the demand of data, service, and performance. Without this improvement, it's unlikely we pay more for 5G service and investment is recoverable. So far we have discussed that densification or the large deployment or of the large number of base stations with different component including baseband unit, radio unit. It required a very large amount of the not only the capital investment but also the operational investment. Now we are moving toward the solution of this problem. The solution of the problem is called cloud or the centralized radio access network, which basically decouple or deconstruct the base station to lower cost, improve performance scalability by moving baseband unit, the digital processing unit of the base station, to a centralized location. This slide is important in which we identify the key feature of cloud RAN. Remember cloud RAN, we are separating the baseband unit from tower to a centralized unit. So that way we can save a lot of money, and we make base station much more lean in terms of the investment because we do not have a baseband unit. Deconstruction of baseband unit to separate radio resources unit and baseband unit. Remember that in a traditional baseband tower, we have two important components. One is the digital component that is called baseband unit, and another one is called radio unit that is also called radio resource unit. So in classical system, both are exist in a single base station. But in case of 5G, we are decoupling these things so that the base station has an analog component that is radio resource unit, while the baseband unit is now moving to a centralized place far from the site of base station. And the connectivity provided by between these two components is called CPRI. CPRI stands for Common Public Radio Interface. This is nothing but a connectivity or transport network that connect the different radio resource unit with baseband unit. Problem is that the CPRI is popular, but it is being a proprietary by the company. So you may require money to use the CPRI unit. Yet this is in one of the important slide of today's discussion. Remember, the center part of this slide is showing you a baseband unit. Baseband unit is not a single baseband, that is a pool of baseband unit, which is now moved from base station to a central location. Transformation from transition to CRAN. This is the important difference between the traditional as well as the centralized or the cloud-based radio access network. The point to be noted is that each baseband unit or a digital unit is now no longer a part of the base station. Rather, they are separating from the base station to some far-flung areas from the base station or a centralized place where the baseband unit of the whole city is centralized physically or logically. You can say that through the cloud. Another company is responsible for maintaining these pool of baseband units. So now the tower is much leaner or it has much more less component. It has less component. It only have a analog unit and few power related units. So now with the densification of 5G unit in the case of CRAN, we do not require a heavy densification investment because the core component that cater the expensive part is the baseband unit. Now all the baseband unit is no longer being used under the single base station. Rather, it is being used under the centralized base station. in pooled. Whenever something is pooled, it optimized. Let's look at the formal definition of the CRAN or cloud RAN. Another name of CRAN is centralized RAN is the architecture for cellular network. It is introduced by China Mobile in 2010. You know that in Pakistan, Zong is the main product or the service provided by the China Mobile. China Mobile is the leaders in the cloud-centric RAN. This is the figure we have already discussed that the baseband unit is no longer a part of the towers. Rather, it has been pooled in a place that which is not necessary in the same location. That is why we call cloud. Remember that whenever we use the word cloud, which means that the storage or the processing has been done in some remote locations, and that is not under your control. Rather, it has been controlled by third party more efficiently compared to the cellular operator. Remember, you are using the Google Drive. The Google have all the data. For example, I upload a lecture, a video lecture of let's say 10 hours video lectures on a Google Drive. I only need a link to share with my students. So all the data is no longer is now in the form of a cloud in some far areas, maybe in USA or in Singapore. If I use the cloud-based storage for my data under Google Drive, these data is not necessarily placed in Pakistan. Rather, this data is placed in some third world, is in first world country, including let's say in America, Singapore. So these big companies have advantage of economy of scale. Likewise, in case of cloud-centric random access network, the pool is now under the control of a company, maybe the same company or some other company, which provide service to a cloud-centric service for the baseband unit. So this is one of the important that you can save money by decoupling the baseband unit from the base station. We already discussed beside the baseband unit, we also have a transport unit or a front haul unit. Uh, I'm going to repeat the baseband unit. Remember that baseband unit was previously discussed to a part of the antenna. Now instead of our single baseband unit, we are having a pool of baseband unit. The difference. Let's discuss the difference between the pool of baseband unit with that of the individual baseband unit. The baseband unit pool located a centralized site function as a cloud or data center. It multiple basement dynamically allocates resources to radio resource units on the current network needs. Remember that baseband unit in a form of pool is implemented by a party or that is just like a data center which have a cloud-based data center which dynamically look at the radio resources. When some region or coverage area do not using the radio resources, it can be used by some another uh, another neighboring cluster or a cell. So it constantly looking at the radio resources and efficiently allocate the radio resources where it needs the most. So it can save the radio resources when you comparing the baseband unit with the pool of baseband unit. We may save a lot of radio resources because it's just like a pool which in through which the resources cannot be unused, and because the company spend a lot of money on the spectrum, and when it is not being used by any reason, then it is a lot of it is a loss of money. So remember that when we compare baseband unit of traditional network with the baseband unit of a 5G network, in baseband unit of 5G network, we use the word baseband unit pool. Pool means not only a single baseband unit, but different baseband units of whole network is now placed under a cloud centric place, which can save a lot of money. And on the other hand, the tower only have the radio resource unit, which is another name of it called the analog unit. So now the 5G tower, if you go at the YouTube or internet, type the 5G tower, you will see a very small tower in very small tower 5G, which is much more simpler. So if it is now much more simpler, the 5G tower is now much more simpler, and it's simpler and it is not as many components as in the case of the traditional base station tower. So in this way, we have a densification of the towers in 5G, but we are decentralizing the component which take a lot of resources, and that has been pooled in a cloud centric environment. So this is how we can save uh, save our network from operational as well as capital expenditures. Now we look at the front haul transport unit, which is connecting the far base stations. Using optical communication, cellular or millimeter wave, the front is the connection between baseband unit and RR units, providing high bandwidth links to handle the requirement of multiple radio resource units. Remember, we connect our calls or our internet from our mobile phone to base station. This is the first step of the network. And the base station is under the load of number of users who are using different applications. Somebody is using WhatsApp, some using the Zoom internet session, somebody is playing the real time games. So these all different data received at the base stations, and these base station receive the signals using radio resource unit. They do not have baseband units. Rather, they transmit all the analog signal from radio resource unit, digitize it, and send it to far-flung areas using the transportation system that is called the front haul. These networks consist of maybe optical fibers or cellular network or millimeter wave communications, and it has to support number of radio resource units, and it use high bandwidth links to handle requirements. Now we are looking at the front haul. Remember, front haul is provide the connectivity between the radio resource unit and the baseband unit. Remember, in 5G, baseband units are not reside reside in the same place, that is the base station. Rather, it moved to far areas. That far area may not be in your country. That is why we call it a radio setup. For example, in case of China Mobile, China Mobile may have base station of Karachi in in a remote location in China, just like a data center for Google Drive. So they can have a control of baseband unit of the whole network under China Mobile. Remember, China Mobile is not only present in Pakistan but also in different part of the world, including Africa. So whenever they have a mass activity, they have the advantage of economy with scale. So front haul is nothing but a connectivity between the radio resource unit and the baseband unit. Baseband units are in a large number are aggregated in a pool as a centralized baseband control. Aggregation means all the different baseband unit are not in a single entity but also in a group of entities that is aggregated. On the other hand, the radio resource unit are stand alone at the remote cells, and this is maybe 10,000 tens of kilometers away from the CPD interface. Uh, the stack of baseband unit at the central also allowed load balancing. What they do at the baseband unit pool. Remember, the baseband unit pool is a part of the cloud random radio access network, in which they not only provide the load balancing. Load balancing means that in some part of the network, some people using networks very heavily, on the other part, the user are not present or using very lightly. So in case they will share the resources of light part or the unused part of the spectrum from one network to another network. So efficient resource sharing of radio resources is possible using the BBU pool. BBU pool is the one of the important component of the cloud radio access network. So load balancing is not easy with the traditional base station, where the baseband unit is only linked with a single base station,
Sir,
radio unit. हाँ बोले.
sorry to interrupt you, sir. This meeting will going to be end after 30 seconds. Next third session will be start after 10 minutes. So this will be
हाँ
the
10
break of
minutes.
this session.
हाँ ठीक है.
I
Okay.
am requesting with all the participant and presenter, we can continue the session after this session. And